Welcome back to Talking Environment. I'm your host, Gevorg Ghazaryan, and today we are going to talk about a topic that shapes how people understand the world around us, but often happens to be quite behind the scenes, and it's about environmental education. And to help us explore questions connected with this, I'm joined by Dr. Jane Dmochowski, and she's a professor at the University of Pennsylvania's Department of Health and Environmental Science, and she will help us to discover these questions. Dr. Dmochowski, thank you so much for
You're so
joining us.
welcome. Thank you.
Yeah, so could you give us a little bit of background of your work, what your work focuses on?
Sure, yeah. So I'm in the Earth and Environmental Science department. We have two undergraduate majors. We have the Earth and Environmental Science students, and we have the Environmental Studies students. So I work with both of those undergraduates. And I teach classes in environmental case studies, which I think we might talk a little bit about because it's a great way for students to learn a wide variety of things about the environment and how to approach environmental issues. I also teach Introduction to Remote Sensing, and I run our year-long seminar for our seniors and doing their senior thesis research and various different classes that I've taught in the past. But I'm trained as a geophysicist, so I grew up in Southern California, did my work there, and as I got to Penn, really started using more of those like geophysical tools. In particular, we might talk about what my work with using satellite images. But as I've been at Penn, saw more and more interest in not so much understanding the subsurface of the Earth, which is what I had previously focused on, but actually our surface and how our landscape changes, how the vegetation changes, and things like that. So that has been a lot of my efforts in the last, 15, 20 years, along with, really thinking about how we educate ourselves, how we educate others, and really the impact that education around environment can have. Yeah.
So what drew you into this field? Why did you decide to pursue this?
Well, I originally went to college to be a physics major. I loved math and physics. And then as I went along that path, I took, as lots of, undergraduates do, general education class. I wound up in a geology class and just loved it. And then I had the incredible good fortune of meeting this woman, Tanya Atwater. And she sort of opened the doors to what is called geophysics. Told me what that was. And I was like, yes, that's what I want to do. And then I just, you sort of follow your path and your interests and your opportunities. And that led me to our department and working with undergraduates. I directed the undergraduate program in Earth and Environmental Science Department for a while, helped to start the Vagelos Integrated Program in Energy Research, done a few different things where I've been able to really be a part of developing or revising curricula around the environment. And that's, I guess, my path.
That's quite a shift from physics. But
Yeah, but I think like the fundamentals of like really being able to break a problem down is something that I learned as I studied physics, and being able to use data, collect data, understand what that data tells us is something that I use a lot in my research, but also in my teaching, and I think that students really can benefit from. So yeah.
Interesting. You've also taught at schools, right?
Yes.
So what
Yep.
made you decide between schools
Yeah.
and universities?
So I took a 3-year leave of absence from my PhD program, and part of that was teaching high school. And I got to teach all different sciences in that high school. And then I taught again a high school and one middle school class early in my time here in Philadelphia. I would say in both cases, I did not go in that direction because I thought it would be my forever path, but it was something that, is sort of one of those opportunities that came about, and that I took it and really learned a lot from it. I would say I have learned the most about how to teach from being in middle school and high schools. I think we could learn in higher education quite a bit from how much, teachers in anywhere from, I'm sure nursery school too, though I don't know how have that experience, but elementary school, middle school, and high school teachers really do a lot of professional development, a lot of helping each other learn to teach, and they observe each other a lot, which we do not do enough in higher education. Yeah.
So that's what bring you to
yeah.
the schools.
Yeah, but I really love research,
That's right.
and I love doing, and I love the really working with more adult learners, in lots of ways, and the flexibility that gives to be able to both teach and do research when you're in higher education is really, which was always, I think, ultimately my goal was to work with undergraduates and do research that applies to lots of people.
Interesting. Yeah. Makes sense. So you have had an experience both in schools and in the university teaching people complex issues in this field.
Yeah.
What would you say? What are some struggles when trying to breaking down some complex issues or general public to understand more about?
Yeah, I think that, I won't project to other people, but when I was younger and I started to, understand the complexities of, let's take climate change, for example, and how we understand that climate change is happening, and really understanding what leads to climate change, the greenhouse effect, all these things. And I think in my 20s thought this is just a matter of making sure other people understand. And I would say that is not, I was wrong. People need to, of course we all need to, students and everyone else needs to understand the fundamentals of these sort of big environmental problems. But also listening and engaging, whether you're, an instructor or a learner or a community member, those skills of being able to understand someone else's perspective, and then also taking, information, whether it's like quantitative data or qualitative information, and using it to make new conclusions, I think is like, that's what I want my students to be able to do. And that's really what I try to do is, so listening, learning about other people, understanding how they got to the conclusions that they got, or why they have the impressions of one thing or another, I've realized is even more important than just like, you must learn. If you know this, then you will agree with me.
Building on to that, how important do you think is just general awareness about these issues important to solve these problems for the general public?
So important. Yeah, I mean, so important. Everyone should understand we all live on Earth. While people sometimes will put a lot of money and talk into like, well, when we're done with Earth, we go somewhere else. I don't think that's where we should be in our problem solving right now. I think when you really understand how we impact our Earth, you start to understand that the changes we make to Earth happen relatively easily, right? We can take a chainsaw and cut down a tree, and that tree's gone, right? And it's really, using a simple example, but it takes a really long time to regrow that tree, right? Very similarly, we drive down the street in our vehicle, and unless we're driving an electric car and that electricity is coming from a green source, we are spewing out greenhouse gases. And as we know, it's really hard to get those greenhouse gases back, right, and locked back up. So I think that everybody who exists on Earth has to understand on some level how we impact the Earth, and how we live with it. We are part of our environment, and we have a huge impact on our environment. and it's not always easy to fix when those impacts are devastating and hurt other parts of our environment. So, I mean, I think it's a fundamental part of all of our existences is to understand. I mean, I think, a lot of cultures do this already, right? We often talk about like we lost a lot of indigenous knowledge, for example, in North America and in other places, as well. And like in some ways, hopefully we can get back to that where every individual understands how we affect the earth and what those effects do and how they then affect us, So, yeah.
Yeah, I think it's really important also for people. Mostly people try to just have awareness about the issue, but not that many people also want to learn about solutions.
Yeah.
So like understanding the issue, I think, is one part, and then the solutions is also another big part.
That's something exactly. Yeah, and it's hard because we want them to be easier, and they're not. And they often involve a lot of sacrifice on a lot of people and adapting. People. We don't like. I don't want to. Nobody wants to like. Well, if I'm comfortable, why would I change? If I have a house right on the beach, why would I want to move it back? Why would I want a big seawall or whatever? So nobody, not nobody. Change is hard, and making sacrifices that you may not see or you may not feel like you see the benefits from right away is really hard for most people. It's something actually I try to kind of get at with my environmental case studies class, where so the design of the class is that we investigate multiple cases or environmental cases, and for each of them, the students might engage in like a reading, or they watch a documentary or listen to a podcast, or whatever it is, read a couple articles, and then they do a pre-class assignment. But really that's just getting them to understand like the fundamentals, sort of like how the issue came to be, what the timeline was, etc. And then in class, though, once they've learned those basics, then they have to engage in whether it's a problem-solving exercise. It could be a debate. Sometimes we do town halls, and sometimes we'll do like a pitch, an elevator pitch to investors. That we do that for our thinking about solutions for our geoengineering case study. But they'll all have, in all of the instances, they're often taking on the role of a stakeholder. So even just the process of like understanding the stakeholders, who are the various people who have something to gain, lose, who will be hurt by a certain solution, who will benefit from a certain solution, who will pay for the solution, is something that they have to investigate in lots of different ways in all these in-class activities. And then ultimately at the end of the semester, but they're working on it throughout, they're developing their own case study on something different that we haven't explored in class. And they have to, write your typical research paper about that, introduce the idea, give the background, talk about the data and details. What's the information that you would look at to better understand this case, or make recommendations, or draw a conclusion. But then they have to also provide what I call Part B, which is how they would teach that case study to the next group of students. Oh. So they really have to dive into like, well, how would I get them to understand the stakeholders? How would I get them to, what fundamentals do they need to know before they go into class and engage in something? And I feel like that is where they really start to learn.
I think
like
the
beyond.
Part is really important.
Yeah.
When you start to teach something, you start to understand it more and more.
Exactly. Yeah. I mean, I definitely thought it was, it was true for me. As soon as I turned around and I started teaching classes when I was still in graduate school, around 25, and actually most of my students were older than me, and I really felt like, wow, I'm really learning now, and I have to sort of try to teach it to someone else. So even just thinking about how you would teach something to someone else, and it actually also gives me a lot of information when I read them about what did they What do they think works? And it also helps kind of, I've been teaching this class for a long time, so it helps me keep my class fresh because the really good ones they know that they may be taught. It gives them motivation to write something that's exciting and interesting and that students might learn from. They're always given that credit so the students can see, I'm doing a case, they'll read, I'm doing a case study with former student. And maybe I'll be that former student one day. And it makes sure that I'm like teaching cases that are interesting to our students and things like that. I do other case studies that either I've developed or, I've been published elsewhere as well, but it's usually about half of them that are former student case studies. Yeah.
What is one interesting, exciting case study that you have worked on that you would like to share with us?
Gosh, I kind of like them all, but so I'll give you one example of one that was written, and published, and then I taught it. Was about dredging in the Potomac River. And so they learn a little about why you have to dredge a river, and then ultimately the activity. So there it was a real incident where they had to dredge the river, the Potomac, and they were trying to decide between 5 different sites. And one of it's not common, but it's becoming a little bit more common, is you can reuse that material to then make wetlands nearby, which of course help the ecosystem, help decrease flooding. So students learn a little bit about that, but then they in class have to sign up for a location and kind of advocate, learn about why that location would be good for the dredged material, and essentially then advocate for why the dredged material should go in their location, whether there's like the Pentagon and there's one near the airport and a couple different places. And in a few of the sites, there's like 5, and 3 of them are really pretty good potentials. The material really could have made an excellent wetland there. And, I give them the categories to think about, et cetera. And then at the very end of class, I give them like what actually happened. What actually happened was that the dredged material ended up in a dump, in a landfill. And then we explore like why that was. And a lot of it was really down to like lack of collaboration, lack of understanding across, state jurisdiction and things like that. And it kind of doesn't just teach them about wetlands or dredging. It also teaches them about how these decisions are made and how it can fail. So it's not like that one. We do one on the Salton Sea where it's a long and complex issue, and they have to then sometimes I put them in groups of like-minded stakeholders or mixed group stakeholders, and they form a task force, and they have to decide like what are we going to do with the Salton Sea, which was kind of like a very large, very salty sea in Southern California that was essentially there by mistake, and now is very salty, filled with a lot of nutrients from the runoff of agriculture. But some people really want that there. It does help birds. There's a lot of benefits to it, a lot of negative, things to it, and so they have to take on different stakeholders and then decide like what should be done in the Salton Sea. Yeah,
that's really interesting.
And then all number ones that the students have come up with on Cape Wind in Massachusetts and why that failed. So many. Yeah, there's great ones. Yeah.
Interesting. Yeah. So I wanted to circle back a little bit on the education part and how we teach people these complex issues. You mentioned about how university students, how you try to teach them, but I also wanted to ask you, what about, you also taught classes to middle school students?
Yeah.
So what about people who are not grown, people who don't understand the issues profoundly yet?
So I'll talk more. You can tell me which direction you want me to go.
Yeah.
I can talk about when I taught that level, but I also now, as part of my outreach and my research, I go into middle school and high schools and work with them and try to, get at what they're interested about their environment. What do they understand about their environment? And also introduce them to the ideas of most of what I do within my science research, which is using satellite images to better understand how our landscape changes, how vegetation changes, etc. So over the last year, I've got into a number of high school and middle schools, and it's great when I have the time to actually be able to go out into a field with them. So I give them a little introduction to remote sensing. So I might show them, I do show them, for example, Landsat, which is one of the longest running satellites.
So
there's
what
multiple.
is remote sensing?
So okay. So remote sensing can be defined really broadly, but essentially it's looking at, in my case, the Earth. You can also do remote sensing on other planets, but or even the atmosphere. But in my sense, it's looking at the Earth from a either satellite or aircraft or even balloon image, right? And so you're trying to understand the Earth below the surface, sometimes subsurface if we're looking at like radar data, and you're using really just spectral information. You're just using parts of the electromagnetic spectrum to understand what's on the surface. And the great thing about that is that we can design these sensors so that we're not just seeing visible light, we're seeing infrared light. We're seeing near infrared light, we're seeing UV, and so using these different parts of the electromagnetic spectrum and putting them together in different ways for each little pixel, like a footprint on the ground, we can identify that. We can do what we call classification. And we can also, so I do a lot of classification. So if we're trying to say, take the entire Philadelphia area and just classify it into vegetation, urban development, and water, right? Just to say like how much green space is there. Then each pixel you can, basically label it 0, 1, or 2. 0 might be we assign that to vegetation. 1 might be assign it to urban.
Is there publicly available data of?
Oh yeah. I almost exclusively work with publicly available data. So Landsat is publicly available data. We're now on Landsat 9. It started in the 70s. You have good data in the 80s. It's not easy necessarily to retrieve and analyze in the way to really get at these things, but more and more it's easier and easier, more and more accessible. In my introduction to remote sensing class, we use Google Earth Engine, which is a cloud-based free platform where you can look up all these different sensors, bring them in. It has a code editor that's written in JavaScript, or you can change it to Python if you like Python better. And you can write little codes to analyze these images, and it's all free, and it's all done in the cloud.
What role would you say these technologies play in trying to break down these issues? Because I think, for example, maps, all this data, just trying to visually also see what's happening.
I have always been a map person, a very visual person. And so I think it's incredible. So going back to these middle school students, so I might be able to show them on a image, okay, so here's the satellite image in like visible light. You can assign like the electromagnetic wavelength that is red to red, and you get like a more or less real image that would look like a photograph, and then hone in on that, and then like look at the pixel where we are, in the school, for example. Or usually I try to talk to the teacher, is there a field nearby? Okay, so that we classified as vegetation. Let's go make sure it's vegetation, and then I have a handheld little spectrometer that they can take out and then take little pictures of, and I can show them. There's a number of different indices of like how green, or there are other indices too, but the most common one is normalized difference vegetation index, which is basically between 0 and 1, super green and healthy, closer to 1, dead brown asphalt, something like that, closer to 0. And so, I might do things, I've done things where like I describe what that is, and then I have them guess what they're going to do, what would be the NDVI out in the field. We go out in the field. The first thing I actually have them do is measure off 1 pixel, because in Landsat, 1 pixel, like one little picture element, is 30 meters by 30 meters, which is huge.
Huge, yeah.
So they're looking at this image thinking they're going to be able to see each other, and then they realize, like, oh, we're all one number in this big field. And so, okay, this big field is going to be one number. What is that number going to be? Is it going to be closer to 0? Is it going to be closer to 1? So that gives them sort of like, I think, like, they start they start to better understand what these images can and cannot tell us. So my goal for remote sensing next fall is to have those high school students at various places in middle school that I've been working with interact with my Penn undergrads, and together try to come up with questions that they could answer about the environment in Philadelphia and with remote sensing. So my students always do their own projects, but I really want to, the work I've been doing has been with a bigger goal of really engaging that community, primarily through the schools, with the Penn undergrads, and making sort of more participatory, at least the participation, starting with like participating in what are the questions we have, right? Because we often can just be told what scientists are working on instead of like, well, but I want to know in my community, this. And so, yeah, that's my goal.
It's also great how the university is also trying to involve the broader population in the community.
There are a
just
lot.
focusing on the university.
Yeah, I think it's really important. I mean, we're a huge part of our community, and it's really important for places like Penn to remain engaged in the communities that they are a very big part of. And for students who come here from all over to understand Philadelphia.
Of course,
it's part of your education, right? Yeah.
And then they can learn and then apply it to their community.
Exactly.
So it's really important.
Yeah, exactly. Yeah.
Okay, so we are going to wrap up in a minute, but what's some final message that you would want people about the work that you do about environmental education?
Gosh, there's so many. I think just the importance for not just learners, but also educators, because really we're all learners, hopefully, is to just always be asking questions. I think that curiosity, if we all remain curious about each other, about our earth and our environment, and like that willingness to engage and learn, is so important. I think that not just for the environment, but for our existence on Earth.
I think curiosity is a big part of
it really is. It really is. Yeah.
I think it's really helpful to when we were kids asking a lot of questions. We just should stick to that more.
Exactly. Yes. Actually, absolutely. We shouldn't stop being like that. Yeah, I agree.
Okay, so thank you so much for joining us, and thank you so much for the insights on environmental education, remote sensing, and telling us more about it.
Yeah.
It was great to have you as a guest.
So you're a great host. Thank you for inviting me.
Thank you.
You're welcome.
So, and to everyone listening, thank you so much for joining, and make sure to follow us on YouTube, Spotify, and Apple Podcasts. Thank you for joining, and until next time.
Bye-bye.